Okay, so this is for Lab 5. Lab 5 is going to go over some functions as well as teach you guys about some very basic math notation. So right now I have a program that's set to just print the value of A. We can run that and we see the current value of A is 5 as we set right here. But let's say I want to make a function that changes the value of A. Or let's say I want to make a function that helps me add 5 to the value of A. So what I can do is at the top, I can define a function, and I'm going to start out with a pass by value function. So the function will return a plus 5, and a is just going to be any number I give it. So because I know I want to return an integer, I'm going to start with int. This is the return type of the function. And then the name of the function is going to be add 5. After that, this is my space for any parameters as well as their data types. So I'm going to pass in an integer and I'll name it x. And then after that, I have my open and close braces. And then any code for the function can go right here. Next, I want to add 5 to any input and return that. So I can simply return x plus 5. And there's my function completed. Sometimes you'll see actually, let's first go and we can see what this does. So I can set the value of a equal to add 5, and then the argument here. So the value of x is just going to be a. So I put a just like this, and then when I recompile and run it, we see a is now equal to 10. A note about function placement. Know that your program is going to parse one line at a time. So if I were to move this down here, once your compiler gets to this line, add 5 has not been defined yet. It's defined down here, so we would get an error here. And here we see add 5 was not declared in this scope on line 10. So add 5 was not declared here. That means we have to prototype the function. If we want to have our function definitions under where we actually use them, we need to make sure they're prototyped. And that's basically telling your compiler, hey, there's a function, it's going to be named this, it's going to return this, and it's going to have these arguments, and I'll define it later. And that's enough. So easiest way to prototype is once you have your function set, you can just copy this portion of it, everything to the left of the open brace, paste at the top, put a semicolon there. And now we see it compiles just fine. For now, I'm going to keep them up here though. Okay, so we have our add 5 function. It takes in a value of an integer. In this case, it's a. So when I say I set a equal to 5 here and I pass into the function, I'm passing a 5 into the function. So x is going to have the value of 5. Next, I'm going to return x plus 5. So 5 plus 5 is 10. And that's going to be returned. So this right here is going to evaluate to the return value, which is 10. I then set a equal to the value that gets returned. So I'm overwriting the value of a with whatever gets returned out of this function, which is 10. And that's why when we print the value of a later, we get the value of 10. So now let's say I want to make another function. Let's say I want to make an add 6 function. But instead of returning the value, I want this function to modify the value for me. So I don't have to overwrite the value after I call the function will automatically overwrite the value for me. So for that, I can change the return type to void, meaning that it doesn't have a return statement. And now I can move on to actually modifying the value. So to do that, what we're going to do is instead of passing in the value of a, so this function is using pass by value, I'm going to use pass by reference. So instead of passing 5, which is the value of a, I'm going to pass the memory address of a, or a reference to a. So instead of passing in an integer now, I'm passing in an int pointer. So this is a different data type, so pay attention to this. Now that I have a pointer to an integer, I can change whatever's at that memory address. To do that, I want to dereference this pointer. So to do that, I put a star in the front here. It's going to dereference it, and I can put it in parentheses as well. The order of operations here might be a little strange, so when you're using the pointers in math, it's good to put them in parentheses. And now I can say equals, and then to get the value, +5, just like this. Alternatively, I could write it a little simpler like this. Oh, and of course, add 6. So I want to change that to a 6. So let's look at the differences between these two functions. Actually, first, let's look at the output. So if I want to, I can do add 6. And because add 6 returns nothing, I don't want to set a equal to void. You can't actually do that. So I can delete that part. And because this function is going to modify a for me, we can see that the value of a is now 11. And I didn't have to reset the value of a in the main function. So let's think about more what's going on here. When I give ampersand a, let's print the value of ampersand a actually. I can print it as an integer. And I'll comment out this print statement. It's going to give me a warning because of the data types. But if I print it anyway, I see I get a big number. And if I run the program again, it's the same numbers, but it will change depending on when you run it. So if I were to run this program again in 10 minutes, then that memory address might be different. But that's exactly what it is. It's a memory address. So it's the location of A. It's where A is being stored in your RAM, or in your memory. So this value of 5 has to go somewhere, and this number is where it's going. So when I pass, this is still technically passing, when I say add 6, this function is still technically passing it by value, but the value that we're passing to the function is no longer the value of A, it's the location of A. So if I pass the location to A, I can still go to that location and change the value that's at the location. And because I'm changing the value at the location, I'm overwriting what is the value of A when I change that location. If you want to think about this like if you write a number on a piece of paper and you want your friend to change the number on the piece of paper, it's not enough just to tell them the value that's on the paper, the number that you want changed. You need to hand them the piece of paper so that they can change it. So by giving your function the memory address of the variable that you want changed, your function can dereference that memory address and change what's actually there, and that will change it in the rest of the program. Okay, that should cover very briefly pass by reference and pass by value. In this lab, the lab wants you to have everything pass by reference. So all of your functions, except for the function calculating y, should look something like this, where you have the data type is an int pointer. So it's a pointer to an integer, the memory address of an integer. You'll also be looking at some math notations. I put it in the PDF, but just to say it again, the two symbols at the start, I'll bring it up here. The two symbols for calculating A, this is the summation symbol. This first one right here is the summation. This is going to take, okay, if we look at this example, this is going to take the sum of all digits that are in the right side here. And you can think of these as a for loop. So we see I starts at 1, I is going to go until n, and along the way it's going to be summing up all the values on the right side here. So this would sum up all the values, I plus 2 for all values between i's 1 and i's n. And then the next one works the same way, except instead of summation, it's the product. Okay, that should be it for this lab. Good luck.